You are in the Extreme Performance Series session called Optimize and Increase Performance of Mission Business Critical Architectures Using VMware NSX and vRealize Network Insight. They had me read the whole title, so it'll be on the audio recording. My name is Todd Muirhead. I'm a part of the VMware performance engineering team. I've been with VMware for about 8 years and have focused mostly on database and storage performance over that time. I'm going to talk a little bit later in the talk about some of the performance testing that we did and some of the results specifically.
Hi, I'm Bob Goldchan, and I'm glad Todd read the title and not me. So, moving on, we'll disclaimer that I think a lot of you have seen, but there's some features, technical feasibility, and market demand will affect final delivery. So that's disclaimer. So our agenda, we're going to be talking about NSX. This is not an NSX session, but we're going to be leveraging NSX and a lot of the features around NSX to do some database and application performance acceleration. And we're going to do this by talking about and introducing the elimination of network hairpinning and intelligent management with vRealize Network Insight. We're going to present the findings that myself, Todd, and Deloitte also validated. And then we're going to talk about vRealize Network Insight and how you can leverage this to identify opportunities to find hairpinning in your topology. And then on with that with the conclusions. So I want to give you a perspective of where we're coming from, what Todd and I have been involved in. And if we look at the typical application, there are about 1 to 2 vCPUs, about 8 gigs of RAM. Database is slightly larger, 4 to 8 vCPUs, around 32 gig of RAM. And what we found is even at these small sizes, or going up to 1, 2, or 4 terabyte databases, the overhead is fairly consistent, around in the neighborhood of 7 to 10%, which is kind of a testament to our hypervisor. It's fairly linear. So regardless if it's Oracle, SAP, MySQL, you're going to see about a 10% performance hit when virtualizing databases. So as I said, Todd and I have been at this for a while. I would say the vast majority of the database best practices that you see on the VMware portal, we've either authored, co-authored, or have been credited with those papers. And what we found is database virtualization, as far as the best practices, it's about a 90-10 rule. So 90% of the best practices are common across all databases. There's about a 10% unique quality around database virtualization. So these best practices, these heuristics, they're fairly well known. It's not a question of can I virtualize my database. The question is more or less, why should I virtualize my database? And we're going to present some options around day 2 operations and the power of the software-defined data center. Being able to do workload management, data growth, planned and unplanned events, and taking NSX, intelligent management, and workload mobility to present the solution and how you can leverage a solution. So again, I'm an architect, staff architect, and we look at NSX as it's a very interesting product. Microsegmentation, workload isolation, security. But as an architect, we're a little bit jaded, and we expect the network to be highly available and secure. So these qualities don't really move us, should I say. So the challenge is how do we position, or how do we find use cases for NSX that would excite architects like myself. And basically, why should database DBAs, why should application owners, why should CIOs care? And the reason is because you can get better performance with NSX, significantly better performance. And it seems counterintuitive, especially with what I just said, that there's about a 7 to 10% performance hit when you're virtualizing databases. But with this accelerated performance, we see it as a game changer for day 2 operations. Conservatively, we're seeing about a 40 to 60% performance gain when using NSX as opposed to virtual distributed switches. This reduces the time to value to the business, and it also elevates NSX to decision makers. So when you're talking about performance, you're going to get the attention of application architects, database architects, and CIOs. And just an observation from VMworld Las Vegas, as well as some of the sessions we're seeing here, is the same question comes up: is how do I get my organization excited about NSX? How do I get my DBAs, my application guys excited about NSX? And if you tell them that you can increase performance by 40%, you're going to get their attention. So I would go with that to let them know. So as I said, this is not an NSX session, but I do want to provide a brief overview of the architecture and the components. Now, at the data plane level, this is where you install the virtualization installation bundles, or VIBs, and these are installed directly into the kernel. And that's the key here, is a lot of the services that emanate at the physical layer are now going to be emanating and controlled at the kernel layer. So you're going to get kernel, very fast operations as opposed to services that are on the physical layer. On the control plane, you have the NSX controller, which manages the logical switches and the routers. And then the management and cloud consumption plane, essentially this is your GUI. So your web GUI is here. But this is the area that we're going to focus on. This is the area that we're going to gain the performance on, because it is at the kernel layer, and you're going to be operating at memory speed or line speed. So looking at this diagram, if you are a network person, you've probably seen this before. You're familiar with hairpinning. If you're an application guy or a database guy, probably not so much. But at first glance, you look at this and you think it's a kind of a networky type of a slide. But if you look on this side, on the left, on your left-hand side, if we're looking at the before and after, so before NSX is virtual distributed switches, after with NSX is with NSX. So first, definition of hairpinning, and what hairpinning essentially is communications that emanate at the virtual layer, go out to the physical layer, and then back to the virtual layer. So it's the latency and the performance hit you're going to take by doing this hairpin. What you see on the same host is that because the services operate at the kernel layer, if they're on the same host, they never leave that host. So your communication is at memory speed. On the far right-hand side, we're looking at different hosts. Now, even if you're still going to get that hairpinning by leaving your virtual network out to the physical network and then back. And on separate hosts, you're essentially just going out to the top of rack switch and then back down. So there's no necessity to go out to the physical layer. So with NSX, you're eliminating this hairpinning. And if you think about it, latency sensitivity applications such as databases or telco applications can benefit tremendously from this. So let's take a step back and look at virtual distributed switches versus NSX. So starting at the far right-hand corner, if you're on the same VLAN, same virtual distributed switch, and different hosts, your traffic is still going to be routed out through the physical NIC. Moving on, if you're on the same host, same VDS, but different VLANs, traffic is still routed externally. So you're still going out to the network. Moving over, same host, same VLAN, but different vSwitch, traffic is still routed out. The only use case with a virtual switch, whether that be a standard switch or a distributed switch, that traffic is not routed externally is if they're on the same host, same VLAN, and same vSwitch. But it's not an enterprise solution because any multi-tier application, you're going to have multiple VLANs. So you can kind of eliminate this, and when you're deploying mission-critical applications, you're always going to be going out to the physical NIC if you're not using NSX. So let's compare that with VMware NSX and how the traffic is routed with NSX. So with NSX, you have the ability to abstract layer 2 through layer 7 network services through VXLAN technology. And VXLAN technology is essentially the encapsulation of the original Ethernet frame that's generated by either the virtual or the physical workload, and then it's padded with some additional information. As we said, we install the VMware installation bundles, and we look at the foundational components, and we're just going to look at distributed switches and logical switches here. So in this case, we have 3 logical switches, which actually appear as port groups on your virtual distributed switch. So it's a familiar construct, and the difference is that these port groups are backed by VXLAN technology. These logical switches are then connected to this distributed logical router, which allows you to route these different subnets internally. And again, the key here is that this is all happening within the kernel. You're not going to the external network. That's how you get your performance gain. So the key takeaway or design goal that Todd and I had was essentially to minimize the network latency by eliminating hairpinning. And what we wanted to do was to identify VMs that were logically related and then contain that traffic to as few ESXi hosts as possible. And what I mean by logically related is VMs that either constitute an application stack or a business flow. And this is not possible in the physical world, so this is the benefit of NSX, one of the benefits of NSX. Now, in order to accomplish the solution that we've designed here and our goals, there's 3 real components, one being NSX. So NSX is the foundational component that eliminates hairpinning, so that gives us our technological advantage. From there, we have workload mobility, so leveraging live migration of emotion. Again, this can't be done in the physical world. You can't move applications from one server to the other. The next is leveraging vRealize Network Insight to identify which VMs are communicating with which VMs and when they're communicating, so that we can migrate the VMs to the same host or different host depending on when the communication is happening. So typical day 2 operations which can benefit from NSX is the enterprise data warehouse. And this is the use case that we tested with an Oracle BI environment. So where you have multiple source databases loading into an enterprise data warehouse. But other opportunities to leverage this technology is with scale-out databases, identifying the busy nodes, or backup and recovery, node configurations, IoT, essentially any data movement within your environment. So we're looking at latency-sensitive workloads, which are databases or telco operations, and any kind of data movement within the enterprise. So with that, I'll turn it over to Todd.
Thanks, Bob. So I think Bob did a great job of explaining the technology, and I want to start off with a story before I get into my results. So when Bob first came to me, we worked on a few projects in the past. He came to me and he said, hey, there's this hairpinning thing, and using NSX, it goes away, and I think it could improve application performance. And I was like, well, I mean, maybe a little bit, but, you know, I don't really think it'd be that big a deal. But he talked to me some more, we kept talking about it, and I was like, you know, maybe there is really something here. So we put together these tests to do some validation on that, and as soon as we started testing, we began to see that there was some pretty big performance gains possible, and then we put together some real test plans and did a set of tests. And that's what I'm going to talk about today. So the test environment that we did, we used an Oracle 12c database. And so there's a database VM, and then there's a client VM. So the data is in the client VM, and we're going to load it across the network into the database. And this one I'm talking about first is all Oracle. We used the NetApp all-flash array so that the storage would be fast and would not get in the way of our performance. So we optimized performance from that perspective, try to make the network the key factor in this performance test, because that's where we were trying to show when you can get performance gains. So I'm going to talk about these 4 scenarios, and Bob's already touched on them, but I'm going to go over it again and explain so that when I give the results on the next slide, it makes as much sense as possible. There's a lot of numbers, and I don't want to get too numbery and too confusing. So in this first slide that we're looking at, this has got the first 2 scenarios where the VMs are on the same host. And when we're using the virtual distributed switch, you can see the hairpin happens, and it goes all the way up out to the physical router and back down, creating this really long path. But when we're using NSX, it stays within the host because the 2 VMs are on the same host. It just goes to the logical router inside the host. All communication happens at memory speed, and this is a very short path, so this is a great scenario. And then the other scenario that we wanted to look at was the VMs on different hosts. So obviously, your VMs are not always going to be on the same host because we've got enterprises with lots of hosts. So we wanted to measure what the impact there was. So in the third scenario here, we've got VMs on different hosts but using the virtual distributed switch. And you can see we've still got a pretty long path out to the physical router. But then on the case with NSX and the VMs on a different host, it does still have to go it goes out of the box now, but it's not as long of a path, right? It just goes to the first switch, top of rack switch, and comes back down, so it's still shorter, okay? And in these tests, what we did was a database load of a bunch of different tables from the DVD store test workload. So it's not just one set of data, it's about 10 different tables. So each of those tables are different. They've got different kinds of data, different column widths and stuff. So you're going to see a little bit of variance in performance across them. We've got some samples here. So like the reviews table, for example, 30 million lines is 14 gigabytes worth of data. Reviews helpfulness is 655 million rows, 17.2 gigabytes of data, for example. So you can see the results here. Whenever we're on the same host, the results are pretty dramatically different in the favor of NSX. About 2x to 2.5 times faster with NSX. Whereas when you're using the virtual distributed switch and it has to go all the way out and back down, it takes quite a bit longer. So this is in minutes. So the reviews table took around 3 minutes with NSX on the same host, and a little longer than twice that time when we're using the virtual distributed switch. If you look on the different hosts column, we're still getting performance gains when we're using NSX. It's not quite as big, but it's still pretty significant. So all of these numbers were much bigger than what I had originally thought we would see when we just kind of talked about it. And like I said, when we first started to see some of these numbers, it was kind of exciting to see exactly how much performance gain we could get doing these things.
One other thing on that slide, can you back?
Sure.
Is that this is a relatively small enterprise data warehouse, so it's 150 50 gig, but our full data load, we reduced the time by half. So from 2 hours to 1 hour. Typical enterprise data warehouse is going to run around 2 to 4 terabytes. So we're talking about loads that are going to go 8 to 12 hours. So now we're talking about significant reductions, reducing a 12-hour load to 6 hours, 8-hour load to 4 hours. This is a lot of time to give back to your business. So although this is a relatively small data set, it shows the power of eliminating hairpinning with NSX.
So this is another chart that looks at the same data, but instead of presenting the times, we're showing the percent difference between NSX and the virtual distributed switch. So this is the percent advantage for NSX for these different scenarios. So, in the 60% range up to 100% in one case faster for NSX on the same host in the blue bars, and the green bars are on different hosts. So we're still seeing a 20 to 40-ish% advantage even when they're on different hosts. So that was Oracle. And before we get too ahead of ourselves, I want to temper things a little bit. So this enterprise database workload with Oracle is a really good kind of best case scenario for this testing that we're doing. And the reason is that Oracle database in particular allows us to do, well, there's other databases that do this too, but allows to completely turn off logging while you're doing a bulk load. They've also done a really good job with their bulk loading program. It's optimized very nicely. So when you do a bulk load, it really pushes the data across the network and into the database very efficiently and fast. So the network becomes the bottleneck, so to speak, in this environment. And there are other environments that are like this as well, and I'm going to talk about another one in the next step. But it's important to note that the amount of the performance gain that you're going to get is going to depend on how important the network is to your performance for the workload or the data loading that you're doing, whatever it is. So by being able to do things like bypass logging for bulk loading, it really allows us to fill up that pipe as much as possible and allow us to take as much advantage as possibly we can from shortening that path when using NSX. So we put together this chart, which I call the funnel chart because it looks like a funnel, where we kind of slotted in different databases as an example of roughly the type of performance gain that you might see with these different databases. And the reason is that they all allow different amounts of, they have more efficient bulk loading or the ability to turn off logging to varying degrees. So the point is that depending on exactly what workload you're doing, what database you're using, the amount of efficiency you're able to get out of your bulk loading process, you're going to be able to get more performance gain or less. Your mileage will vary, is basically what I'm trying to say, and don't expect to get necessarily 70% performance improvement on all of the workloads that you would be bulk loading. Yeah.
Yeah. I think the other thing that we want to point out here is that, as Todd is saying, by using NSX, we're allowing the database to ingest data as quick as it can. So the architecture or the logging mechanism associated with the database becomes the bottleneck. And performance tuning is about identifying the bottleneck, removing it, and then addressing it. So these are out-of-the-box numbers. Is there an opportunity to tune the logging mechanism of the database more and increase these numbers? Absolutely. So I just want to point out these are out of the box. And the other thing, we chose these set of databases for a couple of reasons, and Todd will get into the MySQL use case, but we also wanted to show that NSX is not only enterprise, but internet use cases here. So we've put a couple of the NoSQL databases here around CouchDB and MongoDB. Relaxed logging and eventual consistency are all characteristics of NoSQL databases and essentially no logging. So bottom line is that you can leverage this technique and this architecture for both enterprise workloads as well as internet workloads, so both scales.
Okay, so taking into account what we just talked about here, about how the database type can make a big effect on the performance, we took a look at MySQL as a database target for the same data sets that we were using before. And the reason why we looked at MySQL is it has this notion of storage engines or database tables. And the two main ones are MyASM and NODB. So with MySQL, you can just define, when you create your tables, what type of storage engine you want it to use. And then it will use that storage engine. There's vastly different capabilities for each of the different kinds. NODB is a full transactional table engine. And it requires logging to be on all the time to be able to maintain this transactional capability. So while you can limit logging a bit with NODB whenever you're doing a bulk load, you can't really turn it off. And so as a result, the logging is always going to be happening with NODB, and it's going to be an impact on your performance during a bulk load. With the MyASM table, this is a more lightweight table, and it allows you to completely turn off logging if you want to. So during a bulk load, for example, we want to so that we can put things in as fast as possible. So the really cool thing about this is that I was able to use the exact same virtual machines with the exact same storage, same network configuration, same data, everything's the same. All we had to do was literally a one-line change in the bulk import script where we changed the table type from NODB to MyASM. So we can really see what the impact is of just a slightly different logging mechanism while you're doing these bulk loads across the network, and see how much performance gain NSX is able to give us with each kind. So these are the results. The colors are the same as last time. So green is for the different hosts, and blue is for the same hosts. And we're still looking at those same 4 scenarios, right? So we've got the VMs on the same host, VMs on the different host, with NSX and without. So this is elapsed time, the time it took to load this reviews table. And you can see that the NODB charts on the right are much, much bigger than the MyASM charts. And the reason is that this logging is going on, and it slows the whole bulk import process down quite a bit. The logging is the bottleneck in this case, and not the network. So we still get a performance advantage with NSX of about 10% because we are able to get things across the network faster, but ultimately it's really bottlenecked on the logging that's going on with NODB. Whereas when we look at the MyASM results, we get results very similar to what we saw with Oracle, where we're getting 60 to 70% faster with NSX versus the virtual distributed switch. And this is, once again, because the logging is disabled, the network is the key bottleneck in the performance in this case, and we're able to really push a bunch of data across very quickly into the database with the shorter path that NSX is providing us. So this is another chart that looks at the same test that we just did, that I just showed you, but this is the network throughput. And this corresponds exactly with the previous slide, where you can see that the time for MyASM is much shorter, and the reason is that our network throughput was able to go much higher. We're able to really push a lot more data through. Whereas with the NODB loads, where the logging was causing the bottleneck, our throughput basically stops at the same level for both, almost the same for both NSX and the virtual distributed switch. There's about a 10% difference. NSX is able to get about 10% more, which relates almost exactly to the 10% that we saw on this previous slide where the performance gain is about 10%. So these numbers are like really cool for a performance guy because it all like works out, and it really helps to tell the story really nicely. So when you take the Oracle numbers that we talked about first in combination with these MySQL numbers, it really shows that you can get a nice performance gain with using NSX to enable a shorter path for your network. I passed the baton.
Yep. So before we talk this slide, just a little bit of history. First of all, Todd and I have spent most of our career at VMware kind of defending minimal performance hit you get when virtualizing databases. However, with NSX, we're characterizing small gains in the region of 10 to 30 to 40%, which completely flips the discussion. Now, there is no real performance overhead with NSX. You're getting that back plus more. So, as I said, we've spent our time defending this, and now with NSX, we can say you can get better performance through virtualized software-defined architecture. The other item I want to go over is that I think I published the blog about November-ish.
Yeah, October, November.
And that was with the results of the Oracle test. And then Todd came in and he did all this great work with other databases, so essentially validated those findings. You can imagine this blog got a lot of attention from both internally and externally. And internally, our executive and management team said, these are cool numbers, but you got to get them validated by a partner or an SISO. And it turned out that Deloitte had emailed me and was asking if they could participate in a POC, learn more about how we got to these numbers. And unfortunately, their session didn't make Barcelona, but they presented at Las Vegas, and the results of their testing showed a 2x to 7x performance gain associated with the elimination of network hairpinning with NSX. So triple validation from Oracle to performance engineering to an SISO partner. Now, just in this slide, this is kind of an excerpt of a slide a presentation I did last year around SAP HANA, where I kind of decomposed the network spec and created a virtual network architecture for SAP HANA. And you can see it's kind of complex. SAP HANA is kind of complex, so it kind of begs to be virtualized. But what I really want to point out here is that latency is real. Latency is a real concern, especially with distributed architectures, distributed MPP or massively parallel architectures. And directly from the design spec, SAP says, to avoid performance impact on remote loads, which is the use case that we just talked about, or distributed queries, you want to keep those nodes as close as possible and in the same rack ideally. However, VMware goes one better, right? There's no notion of locality for us. We're not tied to a physical server. We can co-locate those nodes, that VM on the same server, so to reduce the latency to near zero, and again contain the network traffic within the same host when using NSX. So it's a real concern with distributed architectures. So here, I just want to show from an operational perspective, how do you accomplish or how do you adhere to the design goals that SAP is putting forward, and that is to keep the servers as close as possible. If you deployed SAP HANA 2 years ago and now you're growing your database, you have to add some additional nodes. Maybe you have a 4-node system and it's in aisle 1, rack 3. Now you have to add additional nodes to adhere to the design specifications. You're either going to have to recable, schedule downtime with the applications that reside on those servers. So it's downtime, recabling, it's kind of a nightmare. With VMware, again, it doesn't matter, right? We can migrate the applications that were either close to those nodes or on the same physical node, and then adhere to the design specs without any downtime. So this is kind of the promise of the software-defined data center. This is another differentiator with no downtime and no recabling necessary.
So a question on this topic. The tool sets that you have, are they now also able to monitor data traffic with NSX and then basically migrate those VMs towards the correct hosts to optimize the data paths?
Yeah, absolutely. And that's actually the third component of this solution, which is vRealize Network Insight. to give that insight into which VMs are talking to whom, and then to optimize that data flow. So before we get to vRealize Network Insight, I just want to point out that we're just touching on some of the components within NSX. There's a whole set of services. And as the complexity grows, again, all these services are at the kernel layer, not at the physical network layer. So all that latency, as you grow the complexity of your network design, you'll see additional benefits associated with virtualization of your network when using NSX to eliminate that hairpinning. And here's this is another use case that we've come up with. It's around database encryption. And database encryption can be quite expensive from a resource perspective. So all the ISVs have their secret sources, but some of the overhead can range from anywhere from 3 to 30%, depending on I/O and CPU consumption. And due to this high overhead, DBAs are reluctant to use database encryption. However, with NSX, you can use a service composer, which is an orchestration tool, and create firewall rules and associate those with the VMs and protect the database layer without any overhead. And this is something we wanted to prove. Now, granted, this is not as high-level security as database encryption, but it comes at no cost. It comes at no cost as far as the performance goes. So we wanted to test this out. We wanted to make sure that there wasn't any overhead associated with these firewall rules. And although you can, create thousands of firewall rules and scale to, 20 gigabits per second per host, we wanted to create a realistic set of firewall rules to protect our database. So we created these rules around the virtual machine name, operating system name, the port group, the logical switch, and then reran the BI tests. And the results showed no difference. So zero performance hit associated with these firewall rules. And what was interesting is we had this discussion in Las Vegas, and a customer had essentially validated what I just said, is that when they created these firewall rules using NSX and took away the physical device, there was no performance hit, yet there was a performance hit associated with leaving that firewall device in the path. And that gets back to the complexity of the network design. So essentially, if we look at latency, we know latency is measured by the number of packets that are moved across the network and the number of devices that it traverses. So in this case, it would be traversing a firewall device as well as a router. So two opportunities for latency to be included in your overall results, whereas with NSX, it's still done at the kernel. So the arrows on the right-hand side say, as your complexity of your design goes up, you're going to be including more devices, yet the performance of NSX will stay fairly constant, because again, you're doing that within the kernel, and you're doing it at memory or line speeds. So here we'll get to, this is kind of an answer to your question. The rest of this will be cover VRNI. And distributed resource scheduler is a tried, true, tested feature within vSphere. And what DRS does is it's going to distribute and balance the resources across a cluster. Your cluster could be 32 hosts, ESXi hosts wide, and it'll balance those resources across the cluster. That's not what we want, right? We want to exploit locality. We want to make sure that those VMs are as close as possible when we want to reduce the latency. So DRS is not going to do the trick for us. It's more of an infrastructure-based tool where we're trying to optimize the application stack. So that's where VRNI, or vRealize Network Insight, comes in. So what we're doing with VRNI is we're essentially modeling the database behavior, understanding which VMs are communicating and what times they're communicating with each other, so that we can optimize that network traffic when a load is going on, so we vMotion it, and then we also vMotion it back to the original destination when the load is completed. And we do this incrementally as the source databases are communicating with an enterprise data warehouse. And I touched on this briefly, but with VRNI, we can kind of predict the degree of application acceleration, because the known quantities here are how many devices it's traversing and how many packets it's passing through those devices. With those two numbers, we can characterize and model the traffic and determine what the degree of acceleration will be if you deploy NSX versus having a virtual distributed switch. So with vRealize Network Insight, don't let the name fool you. It is more than the network. It's capturing data from vCenter, server, the NSX controllers, obviously, converged infrastructures, and the physical switches. So with all this data, we can do complex correlations up and down the network stack. VRNI is not just capturing data of the network. So this gives us that ability to, as I said, do complex and also simple correlations to optimize that stack entirely. So what we're doing with network, we do with CPU, we do with memory and I/O. Here's just a diagram of being able to actually identify what devices are in the path, and then do the optimizations as well as the estimations as to what your degree of acceleration will be. This is another very useful graph as far as it's the top end talkers. And this you can get an understanding of your application, who's talking to who, at the host level, and also drilling down into the top of rack switch ports. And the other thing which you can determine on an MPP architecture or distributed architecture is which nodes are communicating with or participating in a particular query, and then being able to co-locate those nodes or nodes onto the same physical host to speed up the operations. It also, with MPP architectures, you can determine what your data distribution, if it's write distribution, is it a shard, are you indexing it, is it a partition type strategy, and if this strategy is working well for you. So a lot of information you can derive not only from the network but about the application. So bottom line is we're using NSX to boost the performance by eliminating hairpinning, and then VRNI to kind of optimize and understand the behavior of the application. And here, this is just an example of doing some of those correlations. These are some of the data captures that you can create these dashboards and capture this data, so you can do those correlations, those complex correlations. Now, I want to revisit this Oracle test result, because if you're a network guy, we talked about virtual distributed switch, whether it's on the same host or a different host, you're still going out to the physical network. So if you look at this slide, you look at and you say, well, why is VDS on the same host versus the different host different? They should be the same. It's the same number of hops. And the idea is you would be right if we were looking at the network alone, but we're not. We're looking at the application stack. We're looking at the overall performance of the application stack. So not just the network. There's additional benefits that come along with co-location, and those additional benefits can come in the form of NUMA, the form of L1 cache sharing, or the efficiency of our hypervisor. So we're using VRNI to determine these other benefits. So it's not just the network, it's compute and memory and I/O that you can optimize your stack and identify these optimizations with VRNI. And this is a very important concept because this is kind of the backbone of the software-defined data center, but what we're creating is software-defined architectures to take advantage of this. And with that, I'll turn over to Todd for the conclusions.
Okay, so I'm going to try to summarize through the conclusions the talk in just as few points as possible. So number one, virtualization of databases and other applications has typically been associated with a small amount of overhead forever. We've minimized that with our product, and it's not very large. But with NSX, we actually have the ability or the opportunity to provide big performance gains due to virtualization. Take advantage of the fact that things are virtualized. We're virtualizing the network layer, and we can reduce hairpinning and make the path shorter and optimized between virtual machines and improve that communication. And the test that we showed you, the results are some proof points of that. And then secondly, with vMotion, which is a core capability that we have in our platform, you're able to further take advantage of this serendipitous thing with virtual networking and virtual workloads. We can co-locate things on the same host to improve performance even further on a temporary basis. So you could vMotion things together for the time that they need to be, and then you could move them onto other hosts for other reasons later. Maybe the same VM needs to be co-located with one VM on one day and then another VM on another day, and you can do that with vMotion without interrupting anything. And then lastly, the VRNI stuff that Bob showed you is a tool that we have that allows you to gain insights, that works with the name, by using this tool to look at your environment while it's under load, and you can identify these things during the course of business. So we think that all this differentiates NSX and VRNI on top of our solution to allow you to do what we're calling application acceleration, which is what we've been talking about for the whole session. I think that this is one of the most interesting things that I've gotten to work on in the last few years. It's pretty exciting to see how you can pull several of these technologies together on our platform and really provide some really cool performance advantages.
Yeah, and just to kind of piggyback on the business differentiator here is that we're not talking about simple workload consolidation, being able to consolidate more virtual machines and then get rid of servers, or being able to deploy your applications faster. All great things within vSphere, but what we're really talking about is being able to return time back to your business. Return that time, which is very valuable commodity. And just to give you an idea of what we're talking about here is think about your quarter end close, and typical quarter end closes take about 5 to 7 days, and it's growing. And the reason it's growing is because there's more data sources involved with that close. If you can return 10, 12, 14 hours to your business, shorten that close cycle, then what you're essentially doing is you're leaving your books open longer, and you're going to be reporting more revenue. So this is something that CIOs will just kiss you about. I mean, this is nirvana. This is what they're looking for, is being able to shorten those cycles so that they can report additional revenue to shareholders and businesses. So this is pretty interesting stuff. As Todd said, this is very cool. So with that, we'll take questions. I think we have a mic going around since this is being recorded.
If you have a question, just raise your hand, and we'll get a mic to you. Who wants to be first? Okay, there are some other sessions in the Extreme Performance Series at Barcelona this week. There was one session that Bob mentioned about that Deloitte did along this same topic with the NSX application acceleration. So that was done in Vegas, but it's not here. You should be able to log into the portal and see that one when you get home on the VMworld site. There are some hands on. Yes, there's a question.
On the network, we realize network inside, there must be some suggestions for the firewall rules, or for NSX?
Suggestions as far as what?
For the firewall rules for the distributed firewall.
For VRNI, did you have to make changes to the firewall rules for it to work?
Oh, did I have to make changes to the firewall rules?
Yeah, you see in the network inside there's a possibility, I heard on Partner Camp last time, that there's a possibility to see the firewall rules which network inside says which are out of the communication flows extracted, and you can export it and import it in distributed firewall.
Yeah.
For not only to see the communication diagram, but to combine the flows.
Right, right. Yeah, so essentially what we're looking at is we're treating it as a device. We're treating it as a device within the network path, within the network flow, and then associating those firewalls with that VM. In this case, we associated those firewalls rules to protect the database layer. So that you can certainly see within VRNI. I think the key is that in the physical world, those firewall rules would be associated with a physical device, which would introduce additional latency to the overall performance. With NSX, since it's within the kernel, just like the distributed logical router is in the kernel, there is no performance hit. So that's sort of a benefit within to create those services with NSX within the kernel.
Yes, so I understand, but it was interesting if we can see it, or if we have a demo or some screenshot of it. So
Yeah, I agree. I mean, we were limited with time, but so we didn't capture that on a slide. Yeah.
Okay. Thank you.
Okay.
All right, if there's no more questions,
we'll be here.
We'll be up front for a little while. Thank you very much for coming.